So if I want to find the area under this curve from 4 to 1 as we have there, we're going to use trapezium to find or approximate area under that curve. So let's just quickly draw it out. So basically, I want to approximate the area of this trapezium. Okay? Now, I told you the trapezium formula, which we've been using since year 8, which is that. But this is a more friendlier formula to use to approximate the area under the curve when it's one trapezium involved. And you can see it's basically the same formula. Half comes from the over 2. The h is that, and the a plus b is that. So it's the same formula, just written differently. So let's apply it here. So we got half. Now, b and a, I wrote it here. So a represents the first x value, b represents the last x value. So in this case, that will be 4 take away 1. Okay. Now this f of a represents the y value at those x values. So this is the y value when x equals to 1. So this here is your f of 1. Now to calculate f of 1, how do we do that? Just substitute 1 into the original formula here, which in this case is 1 over 1, which is 1. So that's our first number in there. And for the second one, calculate the y value where x is equal to 4. So f of 4 would be 1 over 4 because you're just replacing it in there. So this is a quick way to calculate the trapezium under the curve instead of using the formula, generic formula. And if you put that in the calculator, you're going to get 7/8 units squared. Okay? Now, like I said, one trapezium isn't the most accurate approximation. The more trapeziums you have under a curve, the more accurate it is because of the less gap you see between the curve and the trapezium. We discussed that yesterday, yeah? Well, I showed you yesterday. So, this is the formula for any number of trapeziums, girls. So you know what B and A is. N represents a number of trapeziums, which is also called subintervals. And then you get the y value of the first x value, y value of the last x value, which I've done here, but the early addition is you've got to do plus 2 times every single other y values in between the first and the x values. So to illustrate, let's have a look at this question. And I wrote down the steps to help you break down this type of question. First step, draw the curve. Now, it doesn't need to be the correct curve. Sometimes you'll encounter equations where you have absolutely no idea how to draw it. Just draw a random curve. Like that. It doesn't have to be accurate at all. In fact, this curve is not that curve at all. But let's just say that's a curve. You don't need to accurately draw the curve. Once you've done that, you want to, a step before this, obviously you want to label 2 to 3. So let's do that. So let's say 2 is there, and then 3 is there. Now, draw the trapezius. In order to know how many trapeziums you need to draw, you need to look at the question. In the question in example 4, it says to approximate the area using 4 subintervals. That means draw 4 trapezius. So that means I need to draw, so we got 1, 2, 3, and 4. So we got these 4 trapeziums. Okay? They're not rectangles, they're trapezius. Once you've done that, step number 3, calculate each unit or dash, because remember we need to know how much it's going up by. If you're not sure by guessing, you can always use this formula which will conveniently help you get each of the dash worth. So that's the last x value, take away the first x value, divided by the number of trapezius, which in this case is 4, and that is 1 over 4. So it's going up by 0.25. So label that in, okay? So there you go, it matches up. Once you've done third step, now you can just sub it into the formula. Alright, so let's do that. So, starting with that, it's going to be a long working out, so b minus a in this case is 3 minus 2 over 2 times the number of subintervals, which is 4. Is that alright so far? Okay, big bracket, f of a, that's the y value at x equals to 2. Okay, so that just means plug back into the function. So in this case, 2 over 2 minus 1, but we'll just write it as it is for now and evaluate everything later. Plus f of b, that's the last one, so the y value at x equals to 3. So then I would write 2 over 3 minus 1. Plus, we've got to get all the y values in between the first and the last. So we need to calculate 2.25 f of 2.5, and f of 2.75. It's a long step, but it is what it is. So if I plug those numbers in there, just watch out for me in case I make any mistake. What am I writing here for the first one? 2.25 take away 1 plus 2 over 2.5 take away 1. And the second last one. Sorry, did I do something wrong? Yeah? So basically that's how you do it. If you put all of that in the calculator, okay, so that's how you use trapezoidal rule. Okay. Now let's have a look at a few example questions where we need to apply this from a different approach. Let's have a look at example 5. So let's just label everything that we know. Girls, from the formula here, what does this represent? The first x value, right? So that's your A. This is your B. These numbers, what does that number represent? The y value of the first x value. Yep. And this one would be f of b. And these are all your y values in between, just like what we've done there. So that's all I needed to show you for that example. Now to wrap it up, let's have a look at question 5a. Sometimes what they'll do is they'll just give you a table. So we know this is A, we know this is B, but the thing that I wanted to point out from here is what's the number of subintervals? Because there's no diagram given, is it? If you are not sure, this is what I wanted to show you. Go back to step number 1. Okay, draw a random curve. Starting from 1, we're going to 9. And then if you label these out, that should tell you how many subintervals there are. So we got 3, we got 5, and we got 7. So as you can see, that's 1, 2, 3, 4 subintervals, which one of the girls said. Okay? So that's one way to calculate the number of subintervals, because you don't want to get these numbers incorrect. But the quick way is, girls, after the first one, you just count to the end. 1, 2, 3, 4. Yeah? And then you plug into the formula and you just get it. Right, girls, that's basically all I need to teach you. Any questions? All right, thanks, girls. Do all of exercise 702.